right, so hi everyone. Welcome back. A very good evening to you all. Myself, Ayush Tripathi, and welcome you all to this post analysis discussion of the last weekly contest 207. And welcome you all. Hope you have enjoyed all the problem. So, before starting the discussion, just do let me know if I am audible and write a quick +1 as a confirmation from your side. And all the four problems were really very nice, and especially the last two problems, the third and the fourth problem. So just simply rate the entire contest on a scale of 10 so that we can improve the upcoming problem set. And kindly please confirm if I am audible. Cool. So without much ado, let's start with the first problem. And I personally categorize this entire contest from easy to a moderate level. All the problems were doable and there is no much prerequisite for all the four problems. So I will be taking this session off camera. So let me select the template and this one. Yes, this one seems good to me. And let me just quickly check if everything is fine. So starting with the first problem, maximum value subsequence. So the problem named as maximum value subsequence. And in this problem, you are given an integer array ARR, and here we have a definition of a subsequence. Subsequence is a sequence that can be derived from array by deleting some or no element without changing the order. So order need to be preserved. And for a subsequence of length k, its value is defined by this expression. So basically all the integers which are the part of a subsequence and minus the sum of integer from 1 to k. For example, and we need to determine the maximum value of a subsequence, maximum possible value over all the subsequence of ARR. So for the first example, we can consider this entire array as a subsequence, and in that case the value will be 5 plus 4 plus 3 minus 1 minus 2 and minus 3, that turn out to be 6. So this is a fairly easy problem, and the idea here is to pick the best element, and the moment when I get the difference less than 0, less than or equals to 0, so it's better to discard the element from there onwards. So let's say we have an array of 4 elements. Let's say we have a 10 and then let's say we have a 2, then a 5, and let's say then we have a 7. So there existed 2 power n number of subsequence. So definitely it is not feasible to check for all the subsequence and their value and then pick the best value. So we can draw a very simple observation. So let's first define the value of the subsequence. So let's say if you have selected the subsequence of length k, then your value will be the sum of all its element. So I can say I can say ARR of x1. So x1 is the index which you have selected in your subsequence plus ARR of x2. So this x2 is the second index which you have selected in your subsequence and up to ARR of k. So basically the last index which you have selected. Right? And then you have to subtract the sum of k integer. So 1 plus 2 plus 3 plus 4 and up to k. Right? So I can write it this way. Summation from 1 to k, and simply you have to subtract this integer I. So this will be the value, and our goal is to maximize this value. So you can let's say the value of k is equals to 1. You only have to select one integer. So what will be the best option? So definitely we are going to select the maximum element, right? And let's say the value of k, it is equals to 2. So definitely we are going to select the 2 maximum element. So yeah, this is the greedy solution, right? This is a greedy solution. Every time we pick the maximum element, right? And in order to pick the maximum element, we can sort this array. So let me write the idea how we can solve this problem. So the idea here is to first sort this array in a decreasing order. And as long as value is greater than 0, then we pick the element, otherwise not. Right? So then simply pick the element. So pick the element if the difference is greater than 0. And what is the value of a difference? It is the element value AR of I and minus I plus 1. So here I have considered the 0 base indexing. So if you pick the element which is at index 0, that would be the largest element, and then you have to subtract 1, right? And if this difference is greater than 0, then we are going to pick the element, right? And in the else case, we simply break the loop, because from here onwards all the differences would be negative. So it's better to avoid the element. And this is the way how we can generate the best possible score. The time complexity in this case would be n log of n base 2 because of sorting. So let's just quickly dry run on the same example. Now here if you sort this array after sorting, then this array would be 10, 7, 5 and 2. Now here what I can do, I can just simply select this element 10. So my value would be equals to 10 and corresponding integer would be 1. Just simply subtract 1 plus 7 minus 2, right? And because of this difference is greater than 0, this difference is also greater than 0. Then plus a 5 minus 3, right? And then I can say, can I say this thing 2 minus 3? Sorry, 2 minus 4. Can I say this thing? No. It's better to discard this element 2, because this simply decrease your total score. Because here the differences are less than 0, so I'm going to simply discard this element 2. So this is the complete solution. And now let me show you the implementation. So simply sort this array in a descending order. taken the size of the array, initializing the answer with 0, and this is nothing but difference. And if this difference is less than or equals to 0, then simply break. Otherwise, we are going to simply add this difference in my answer. And finally, I will return this answer. Write a quick +1 if it is clear to you. The first problem. Now coming to the second problem, perfect square difference. So in this problem, you are given an integer array ARR, and the task is to find the number of pair of integer I comma j such that I is less than j, and j should be less than the length of the array, basically not should be out of bound, and the absolute value of these two integer must be a perfect square. Then I can say pair I comma j is valid, and we need to count the number of valid pairs. So the very first thing, constraints are standard. Length of the array can be up to 10 power 5. So definitely we cannot iterate over all the possible pair of I comma j. We have to do something better. So that something better is a contribution technique. So in most of the such problem can be solved with the help of a contribution technique. So contribution technique simply says that instead of checking for all the possibility, simply fix one entity and find the contribution. And in this way, if we sum the contribution of each and every entity of the problem, then that would be equals to my total final answer. Now coming to the solution. So we have an array ARR, right? And we have to find the number of pairs of I comma j such that the absolute difference between the integers ARR of I minus ARR of j, this should be a perfect square. Right? And on the other hand, we also have to fulfill one condition. I should be less than j. This is another condition which was mentioned in the problem statement. So the idea here is to use a contribution technique. So how we can use a contribution technique? So we can simply fix one index and just simply find all the possible pair with that index, corresponding to that index, right? So as of now, let's fix the index j. You can also fix index I. That would be totally up to you. but the idea would be remain same. So fix index j, right? And if I fix index j, then what we are looking for? We are looking for the valid value of I. So that is find the contribution of index j. That would be equals to number of valid I such that the value of I is less than j, and the absolute difference of both the element should be a perfect square number. This should be a perfect square number. Cool. Now let's draw some observations. So the very first observation is a constraint. If my rating is 2100, how much I will lose today? So actually, I'm not sure about this. So that's why I'm not going to claim anything. But you can check after the contest. So the very first observation, let's draw some observation. So the length of the array, which is n, and it can be up to 10 power 5 only, right? And the most important constraint, the element value. The element value can be up to 10 power 4 only. And this is clearly mentioned in the problem statement. So the element value can be up to 10 power 4. That is, perfect square number would be not more than 10 power 4. So how many possibility we have for the perfect square root? So the count of a perfect square root would be no more than 10 power 2. And we can iterate over all those perfect square numbers. So with this idea, we can iterate over all perfect square roots. Do not get confused. Perfect square number at this point of time, we are considering the perfect square root, not the perfect square number. So the number of count of a perfect square root would be not more than 10 power 2, because 10 power 2 square would be 10 power 4. So there would be not more than 100 perfect square root which are less than or equals to 10 power 2. So we can iterate over all of them, right? And yes, then for every we have fixed index j. So for every index j, we need some information from the left hand side, and which we can do while preprocessing the array. Not exactly the preprocessing, but in a meantime. So index 0, index 1, index 2, index 3, and then our current index which we have fixed, index j, and up to index n minus 1. So for every index j, we are interested to know the valid index I, and the value of index I must be less than j. So we need some information from the left hand side. So we can keep track of this information while building this array. While processing this array, iterating over the value from 0 to j, right? So this is my array ARR. Now, if you know the value of ARR of j, then what will be the potential value for ARR of I? So the potential value for ARR of I, so let me write here. So the possible value for ARR of I would be let me first write a for loop. So for j is equals to 0 and then till n minus 1. Now for every index j, I'm going to iterate over all the perfect square number. That would be nothing but the square of a perfect square root. So let's call this integer p. So p is equals to 1. So this p is nothing but the perfect square root. And while p square, that is p into p, is less than or equals to 10 power 4, the maximum element of the array, right? Because if your perfect square number exceeds the 10 power 4, then it does not make any sense. It does not make any sense because it is not possible, right? And you can also replace this 10 power 4 value with the maximum element of the array, which I have done in my implementation. Then p plus plus. So this inner for loop will run not more than 100 times, 10 power 2. Now you know the perfect square number. You know the value of ARR of j. So what will be the potential value of ARR of I? So the potential value for ARR of I would be p square plus ARR of j. The another value for ARR of I would be p square, not p square, but actually ARR of j minus p square. These are the two potential value for ARR of I. And now you consider the absolute value between AR of I and AR of j, then that would be equals to a perfect square number p square, right? So now we are interested to know how many integers we have previously which has these two values, right? So for this thing, what I can do, I can use a map data structure. And actually this is a very standard problem. So for here, I can use a map data structure. So map data structure which store the key value pair, how many integer we have with a particular value, frequency of all the integer, right? And before moving to index j plus 1, I'm going to simply hack the current index j. So answer plus equals to map of p square plus ARR of j. Basically, I just simply expanded the absolute value. Cool. And after this inner for loop, I'm going to simply hash the current index. So map of ARR of j plus plus, right? And let me write this thing also. Now after this, if the value of ARR of I, either of these two value, then in that case the absolute difference of ARR of j minus ARR of I would be equals to p square, which is a perfect square number, right? So in this way we can solve the problem. The time complexity would be n multiplied by 10 power 2. This inner for loop will not run more than 100 times. And the value of n can be up to 10 power 5. So that would be order of 10 power 7. So which will pass all the test cases in 1 second. So this is the complete solution for the second problem. Write a good plus one if it is clear to you. And here we have the same implementation. Find the maximum element. You can also replace this the maximum value with a 10 power 4. Then taken the size of the array. Then here we have our map. Initializing the answer with 0. Iterate over all the indexes. And actually here I have mentioned integer I, but you can simply replace I with the integer j. Then iterate over all the perfect square root. And this is what we have discussed. And finally, I will return this answer. So write a quick plus one as a confirmation so that we can discuss the next problem. I'm looking forward for your acknowledgement. Write a plus one so that I can discuss the third problem. In the first question, it says that order should be preserved. Then why the sorting? The reason why I have sorted this array, because if you just simply write this formula, so that would be nothing but the sum of all the integer which you have selected as a part of a subsequence minus the sum of a first k natural number. And that's the reason why we can sort this array. They simply take in this way. What if the value of k is equals to 1? That is a subsequence of length 1. So definitely you are going to select the maximum element. What if the length of the subsequence is 2? So we are going to pick the 2 maximum element. As long as the difference is greater than 0. Now coming to the third problem, and this was also a really nice problem. And for this problem, there is a prerequisite. And the same problem can be seen in the last contest, 206. So you are given an array ARR. The task is to find the length of the longest special subarray. And a subarray is a special if the following condition hold. There exists an integer such that ARR of k is divisible by ARR of I, and there exists an integer k such that ARR of k is divisible by ARR of j. And and yes, we need to maximize the length of the longest special subarray. So if we take the first example, then we can consider this entire array and it is valid. It is a special subarray. So here the integer I, it is equals to 0, basically the first index, and integer j, it is equals to 4, the last index. So we have integer 2, which is divisible by 1, and we have integer 4, which is divisible by 2. So yes, it is valid. And in this case, we don't have any subarray which is valid. So let's see how we can solve this problem. So I'm going to start with the constraint. The length of the array can be up to 10 power 5 and the element value can also be up to 10 power 5. So the very first observation, the number of divisor of any integer which is less than or equals to 10 power 5 would be not more than 128. So 128 is kind of a upper limit. So let me write this observation, which is really very important. And the same observation was required for the third or fourth problem of last weekly contest 206. And this was the main observation to solve the problem. So number of divisors of any integer a of I is less than or equals to 128. Now some of you might ask that how I come to this figure. So for this thing, I just want to suggest an article and Code Forces article. So you can go and just read about this article. So amount of divisor of n. And here someone has mentioned that we can use cube root of n as the approximate value, where approximate value for d of n. D of n is the number of divisor of integer n, right? So cube root of 10 power 5, which would be a two digit number. So this 128 count is more than enough. And you can just simply go and search for this block amount of divisor Code Forces, and or you can just simply note this a blog ID and just go and read about this block. So I'm going to use this upper bound 128, right? So this simply means we can iterate over all the divisor of integer I of every integer AR of I. So this is my first and the most important observation. Now the second observation, let's say the subarray from index I to j is valid, or I can say is special. So let's say we have a special subarray from index I to index j, right? So what does it mean? It simply means we have a two integer. Let's call this as a k1 and k2. So we have a two integer k1 and k2 such that ARR of k1, it is divisible by ARR of I, and let's use this k2 integer k2 index k2 for j. So ARR of k2, it is divisible by ARR of j. Now just tell me one thing. In order to maximize the length of the special subarray, what if we decrease the value of I? So what I'm trying to say, let's simply decrease the value of I. So error of I1, I can say I1, which is less than I. So we have some indexes, then index I, and then we have index j. Now tell me one thing, whether it is valid for index j or not. So we need to satisfy two conditions. The condition for AR of I, we must have some multiple of AR of I, right? That is I can say we have some integer which is divisible by AR of 5. And in another way, I can say we must have some integer which is a multiple of AR of 5, right? And in the same way, I can say we are looking for some integer in between which is a multiple of AR of j. So just tell me one thing: do we need to bother for the condition for AR of j? No, because if you expand the array, if there exists some integer AR of k2 in between, for example, let's say this is your integer k2. Now we can use the same integer k2 for I1 also, right? So that's the one observation, that is we don't need to bother for AR of j. Once the condition is satisfied for AR of j, then we don't have to change the index j. Because if you change the index j, if you change the index j, let's say you decided to select this value j1. Now in that case you won't get the maximum length. So we are looking for the farthest index j, right? We must have the distance between I and j as large as possible. Now with these two observations, let's come to the algorithm. It might be possible when you have some other way of implementation, but I'm going to discuss how I have implemented the solution. So here also I'm going to use a contribution technique. That is, I'm going to fix one index, let's say index I, and then I'm going to check for the farthest value of j. So let me write this thing. So in this problem also, use the contribution technique. That is, fix index I. And do not get confused, it is totally up to you. You can also fix index j and then find the smallest value of I. So I'm going to fix index I, and after fixing this index I need to know the farthest value of a valid j. So the farthest index j, such that the subarray from I to j is valid. Now how I can find this farthest index j efficiently? So we have our current integer AR of I, then we have some integer in between, and then we have our index j. This is the farthest index j. So to claim this index j is valid, we must have a two indexes k1 and k2, such that AR of k1 is divisible by AR of I, and k2 is divisible by ARR of j. Then only I can say the subarray from I to j is valid. But how we are going to find these two values? How we are going to check these two conditions? So the very first observation, this I should be greater than j. We can just simply consider one direction. This I should be greater than j, because as per my claim, the subarray from I to j. So I should be less than j. So for every index I, we need some information from the right hand side. So let's do some pre-computation. For every index, I'm going to find the smallest index, which is the multiple of AR of I. So for that pre-computation, let's declare a map, and one can also use an array, but in my implementation I declared a map. So let's name this map as ND. So this is for the pre-computation wala part. So this is my pre-computation. And I'm going to repeat this thing. That is, it is my way of implementation. You might have some different logic, but the idea would be same, that we can iterate over all the divisor. So for the pre-computation, let's declare a map. So the map is named as ND. So ND of AR of I. So what it will store? So it will store the smallest index, which is a multiple of AR of I. So let me write this thing. So it will store the smallest index at which the element is a multiple of AR of I. And how we are going to perform this pre-computation? So it's actually very simple. So let's say you have a integer 12. So let's say this is your integer 12. And what are the divisors of 12? So the 12 has a divisor 1. 1 is a divisor of 12. Then we have a divisor 2, 3, 4, then 6, and 12 itself, right? So now in my in my map, in this my in my map ND. So actually this information I will store in my answer array, but actually this is map which I am going to use to build my answer array. So this is my answer of I. So answer of I will simply store the smallest index where the element is a multiple of AR of I. Now how we are going to build this array? So let's say we have integer 12, and let's say then we have some other integer, and let's say then we have integer 3, and let's say we have another integer before this integer 3, right? So what are the multiple of 12? So let's just first look at this value. So the multiple of 12, it is 1. Then multiple of 12, 2. Then 3, 4, 6, and 12. And we all know we can iterate over all the divisor. So basically, what are the divisor of 12? So these are the 6 integer which are a divisor of 12, right? So what I can say, I can use a map. So let's name this map as ND, and this map ND will simply store the index at which at which we have seen this integer x, right? So this ND of x will simply store the index at which x is present. So smallest index which has value. So this is actually fairly simple. Corresponding to the value, we have the index, right? So now, now in future, when we were processing this integer 3, now what I need to know? I need to know the smallest index where the element is a multiple of 3, right? Then I get to know that the smallest index would be nothing but the index of 12. So I can just simply say answer of I, it is nothing. Answer of I, it is nothing but ND of AR of I, right? The smallest index where element is a multiple of AR of I. So in this way we can do this pre-computation, and this will become my potential value for AR of I. So this is your AR of I. This integer 3. It is your AR of I, and this one is your ARR of K1. Now we have this information. Now after this pre-computation, what is the next thing that we are looking for? So the next thing that we are looking for is the farthest value of j, right? Is the farthest value of a j. So after this pre-computation, the task is to find the farthest value. So I am new to GFG. How frequently does the contest happen? So the contest happen on every Sunday from 7 p.m. onwards, and on every Sunday we have a live analysis. So after this, we need to find the farthest value of j. Now, how we can find the farthest value of j? So the very first thing, we already have this information in my answer array. Now the next thing, I need to check for the index j. So we have index I, so ARR of I. Then I know in between we have a integer k1, which will be given by answer of I. And now know I need to satisfy the condition for j. So for j also we can use the same thing. So simply iterate from 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 right to left, from right to left. So before processing the index I, we have the information from I plus 1 to n minus 1. So that's the reason why I have iterated from right to left. So this is index I. Let's say this is index I. So before coming to this index, I do have the information from I plus 1 to n minus 1. Now here I am interested to know the farthest value of j. Now how I can get this farthest value of j? So this can be done with the while pre-computation. For every integer, I just simply check whether we have a divisor from on the right hand side or not. So that is, first I'm going to process this element, the last element, and for this element I'm going to check whether we have a divisor or not. Then I'm going to process this element, that is n minus 2. I'm going to process this element, and now I'm going to check whether this element has a divisor on its right hand side or not. Then next time I'm going to process this element, and then I'm going to check whether I have a divisor on right hand side or not. Then I'm going to process this element, and then I'm going to check whether I have a divisor on a right hand side or not. And if I have a divisor, then this would be the potential value for k2, right? So so before coming to integer I, before coming to integer I have the information from the right hand side. That is whether we have any integer. So let's say we have some integer. This is integer k2, index k2, right? So this integer k2 has some divisor on a right hand side. So that would be index j. That would become my index j, right? So in this way we can solve this problem. So to store this information, what I can do, I can use another map. So let's name this map as a last index. You can also replace the map with an array. It's totally up to you. So last idx. So last idx of val, it will simply store the index which has this value. So index, or I can say the farthest index. That would make more sense because our goal is to maximize the length. So farthest index with value val, right? So for every integer, what I can do, for every integer, what I can do, I can just simply iterate over all its divisor, and for every divisor, I'm going to simply check whether the same divisor has been seen in previously or not. So let's say I'm at index I, So let's say I am at index I. So I'm going to iterate over all its divisor, and for every divisor, I'm going to check whether we have some. Let's say this is 20. So let's say this integer is 20. So what are the divisors of 20? So the divisors of 20 are 1, 5, and 10, and 20 itself, right? So now I'm going to just simply check the farthest index which has one of its divisor. For example, let's say 20. Let's say this index is having value 5. So this will be my potential value for j, right? This would be my potential value for j. And I'm going to store this in a universal variable max. So let's use a universal variable max, and this will store the universal value of j. Because as per the discussion at the beginning, just look at here. If you got the valid value for j, then we can use this value of j as a universal value. And then we keep on decrementing the value of I. That is, consider I1, then I2, and so on. Decrease the value of I in order to maximize the length of the subarray. Right? So we use this integer as the universal value. So rest everything is implementation. Now, if there is some doubt, then that would be clear, must be clear after going through the implementation. So this is the method that you need to complete longest subarray. So first I have taken the size of the array. Then here we have a map which is named as a fact, and this map will simply store all the divisor for every integer. So find the maximum integer. This is very similar to the sieve of Eratosthenes, so which is the prerequisite for this problem. So I iterate over all the integer from 1 to max, and for all its multiple, simply push this integer I. Right? That is, I is a divisor of j. Cool. And then for every index, I'm going to find the next divisible element. That is, for index I, tell me the smallest index which has the multiple of AR of I. That's the simple thing. So for this, I have another utility method. So taking the size of the array, then initializing my answer array, then this is my map, and this map is used to store the nearest index for each divisor. Right? So again, the idea here is to iterate from right to left, and if the current element is present in a map, then tell me the index of a multiple of AR of I. So this is nothing but the smallest index of a multiple of AR of I. So I'm going to store this at index answer of I, and then I iterate over all its divisor, and for every divisor I'm going to store the index I. Right? That is, if in a future, if I got any of the divisor, then for those divisor, the index of the smallest index of the multiple would be I. Then finally I'm going to return this answer. And after getting this information, the idea for the final traverser to find the farthest value of j. So I iterate from n-1 to 0, then find the maximum value of j. So this is my variable max, and it is kind of a universal value of j, because once I got the valid index j, then I don't need to change this index j. So I iterate over all the divisor of the current integer, and just simply check whether we have seen this divisor or not. And if we have seen this divisor, then that would be the potential value for j. The index of that integer would be the potential value for j. Right? And here I'm going to simply check whether it is valid or not. Whether the subarray from I to max, that is a universal value of j, is valid or not. And if it is valid, then update the answer. and also we are going to hash the current element, right? And if it is not present in my map, because we are interested to know the farthest value, farthest index. So if it is not, then only. So let me just quickly explain the entire idea again. So here what I did. So here I fix the index I, and for the index I, first I'm going to find the smallest index which is a multiple of I. So this will be my value of k1, right? And then the second thing, this is my pre-computation. Then the second thing, iterate from right to left. Iterate from right to left and find the farthest index j, which is valid. So find the farthest index j which is valid. And once I got any value of j which is valid, then I don't have to update this, right? The idea here is to take the farthest value of j. And for this thing, I'm going to simply iterate over the divisor of any integer, and for every integer I'm just only I'm for every divisor I'm looking to know which is the farthest index at which we have that divisor. That will be the potential value for j. So this is the complete solution. For the third problem, the time complexity would be n multiplied by d, where d is the number of divisor of any integer. That would be not more than 128, and actually it is much lesser than 128, and I believe it is less than 100 also. So the time complexity would be not more than 10 power 7, which will pass all the test cases. And if there was some confusion for the third problem, then what I would suggest, you can go and watch the rewatch the solution for the third problem, and just take a multiple pause and analyze each and every statement which I have given. And it's better to do a dry run for some example. Now, what I would suggest, try to solve this problem by your own. And this is a pretty easy problem, and what I believe it is a easier than the third problem, because this problem is based on a very standard DP reconciliation, which is for the palindrome, to check whether the substring is a palindrome or not. So now coming to the last problem, you are given a string s and t, and your task is to find the length of the longest palindromic substring of s that is also a subsequence of t. So problem statement is fairly straightforward. Now let's see how we can solve this problem. So we are interested to know the length of the longest palindromic substring in a string S. That is also appears as a subsequence in a string T. Right? And the best part about this problem is a constraint. And that's what I would suggest to everyone. Before coming to the solution, just first analyze the constraint. what is the bandwidth which are provided to us. So the length of the string can be up to 3 into 10 power 3. That is, if we write any square solution, then that would also work. That is a quadratic solution simply. So the length of the string and s and the length of the string t would be less than 3 into 10 power 3. That is, a quadratic time solution would also pass all the test cases. So that the idea here is to first to build a DP array, and the reason for the DP array is to check whether the substring from I to j is a palindrome or not. So we are going to build this array beforehand so that in future we can check in a constant time whether the substring from I to j is a palindrome or not. So this will be my first step. The first step is to build DP array. To check if a substring from I to j is palindrome or not. And how we are going to build this DP array. So to build this DP array, the recurrent solution is very standard and very straightforward. For example, let's say you have a character s of I, that is index I, then index I plus 1 and up to index j minus 1, then index j, s of j. So we are interested to know whether the substring from I to j is a palindrome or not. So for this thing, one observation that we can draw, the character at both the end must be same, right? This s of I and s of j, both the character must be same. And the second condition which is required, the substring which is in between must be a palindrome, right? So for example, let's say A, B, A, then B and A. So let's say this is index I and this is my index j. So to claim this substring as a palindrome or not, the very first thing, both the character must be same, right? And the substring which we have in between must be a palindrome. So that is, with the pre-computation of a smaller length substring, we can build the answer for the larger length substring. That's my general idea. So dp of I would be dp of I plus 1, dp of I comma j. This is simply equals to two Boolean expression. The very first Boolean expression, s of I must be equals to s of j. And if it is not true, then it is not possible to claim that then I to j is not a palindrome. Simple funda. So this need to be true, and dp of I plus 1 till j minus 1, that is a substring in between. This need to be a palindrome. And if both the conditions are true, then I can say I to j is a palindrome. So this is my pre-computation. Now after the pre-computation, I can iterate over all the substring, and in a constant time I can claim whether it is a palindrome or not. Right? So let's iterate over all the substring. So iterate over all palindromic substring. Or instead of saying all the palindromic substring, let's say all the substring. All the substring of string S. and then I'm going to check whether it is a subsequence in a string t or not. So as of now, let's remove this condition. Whether the I'm going to iterate over all the substring. That's my simple funda. So the substring from I to j, right? And how we can iterate over all the substring? So run a for loop, from I is equals to 0 till n minus 1. Then run another for loop from j is equals to 0, not from 0 but from I, because as per the claim the substring is from I to j. So that's why I should be less than or equals to j. So for j is equals to I till n minus 1. So what are the information that we need to know? So the very first thing, I to j must be a palindrome, right? And now the second thing, I to j must be present as a subsequence of a string t, right? So for that thing, what I'm going to do, I'm going to use a sliding window technique. So now I need to check if it is a subsequence of a string t or not. So to check this thing, I'm going to use a sliding window, right? And along with the sliding window, I have some greedy idea along with the claim. So it is not exactly the sliding window, but a sliding window plus some greedy idea. Cool. So let's say we have a string s, then we have a some leading character, and then let's say we have a substring a, b, a, then b and a. Cool. Then let's say we have a string t, and let's say it is equals to character g, then let's say character a, then again a, then let's say b, a, and let's say character m, then b, a, and b. Cool. So the very first thing, this is my index I, and this is my index j, right? So before coming to this index j, I already processed all the values from I to j minus 1, right? That is, I already have this information whether the substring from I to j minus 1 is present as a subsequence in a string t or not. Because if the subsequence from I to j minus 1 is not present as a subsequence in a t, then it is not possible to have from I to j, right? So I already have this information. I can already pre-calculate this information while iterating for the value of j, because we are iterating from j is equals to I till n minus 1. That is, I already iterated over the previous substring. Cool. So for this thing, what I can do, I can use a variable. So let's name this variable as a variable k, and I'm going to initialize this variable k at here. That is before this inner for loop. So here k is equals to 0, right? So now what this k is equals to 0 will store. So we all know the very first thing we iterated from j is equals to I, right? And then I'm going to simply check. Then my variable k is at here. So my variable k is at here. K is equals to 0. So k is pointing to character g, right? Now I'm going to check whether the character, whether t of k, whether it is equals to s of j or not, right? And if it is equal, then it's an happy case. Then it's an happy case, that is we got both the character match. So it is equal, right? So it is not equal. So So if it is not equal, then I'm going to increment the value of k. So else increment the value of k. That is take me to the next index. I'm going to compare with the next index, right? So the next character is a, right? And now it is equals to s of j. So it's an happy case, right? And this is my greedy idea. The moment when I got the character that we are looking for, we are going to immediately match both the character. Because if you are going to match the character A of a string S with some future occurrence of character A, then this is not a best idea. Because if you just simply match as soon as possible, so that we can accommodate more character in the future. And this is a very standard greedy idea to check for the subsequence. If I got the character, then immediately match, so that we would have more choices in the future, right? So both the character got matched, and after both the character got matched, just simply check whether I to j is a palindrome or not. So we can check this thing with a DP array, right? And if it is a palindrome, simply update the answer. Now increment the value of j. Now j is pointing to character B. Now I'm going to do the same thing. I'm going to do the same thing, that is increment the value of k and check whether both the characters are same or not. So both the characters are not same, then increment the value of k. Again both the characters are same. So now we are going to match both the character, right? As early as possible. Now we simply check the moment when we get the character, we simply check whether the substring is a palindrome or not. So the substring is not a palindrome, so just simply skip it, right? Then increment the value of j. Now j is pointing to character A, right? So again increment the value of k, and now both the characters are same. We immediately got the character, same character. So just simply consider this character A. Just simply consider the character A. We got the character, and now I'm going to simply check whether this substring I to j is a palindrome or not. And it is a palindrome. Update the answer, right? Then increment the value of j. Now this value of j is pointing this character B. Then increment the value of k to check for the next character which we can match. So then character M, both the characters are not same. Skip it. Then we got a character B, and now both the characters are same, right? So both the characters are same. So I'm going to immediately pick this character B. I'm going to immediately pick this character B, and now I'm going to check whether the substring from I to j is a palindrome or not. So it is not a palindrome, so skip it. Then increment the value of j. So now j is pointing to character A. Now again I'm going to simply increment the value of k. So simply increment the value of k. And now we got both the characters the same. So just simply pick the occurrence of A. And the moment when you got both the characters same, just simply check whether it is a palindrome or not. And yes, it is a palindrome. So simply update your answer. So in this way we can check for both the thing, whether it is a palindrome and it is a part of a subsequence or not, right? So the general idea here that we already have some information from I to j minus 1 onward, so we don't have to iterate over these characters. If these characters are the part of a subsequence, then we only have to check for s of j, right? So then what would be the time complexity? So the time complexity in this case would be n square. So basically n for the outer loop, and then for the inner loop, so multiplied by the length of then multiplied by n plus m. N plus n. Yes, this will be the time complexity. So here m is the length of a string t. So this variable k will run for at most m time for the complete iteration of this inner for loop. So the complete iteration of this inner for loop would be n time, right? And so n plus m. This would be the total time complexity. So this can be written as n square plus n into m. Now coming to the implementation. So this is my DP array, and this is my pre-computation. That is all the substring of length 1 are a palindrome, and for the substring of length 2, we can just simply make a strict check. If both the characters are same, then only palindrome, otherwise not. And actually, we don't require these two variable. Yes, we don't require these two variable. Then we can fill this a DP array for all the palindrome of length 3 greater than or equals to length 3. So I iterate over all the palindrome of all the substring of length 3 and greater than 3. Then this is my simple reconciliation. So dp of I comma j, it is equals to both the characters must be same, I and j, and the substring in between must be a palindrome. Then only I can say I to j is a palindrome, right? Then initializing the answer with 0. Then taking the length of the second string t. Now I'm going to iterate over all the substring from I to j, right? And this is my variable k, and here we have a variable found. Then keep on incrementing the value of k as long as the character is not equal to s of j. And the moment when we get the character which is equal to s of j, then we are going to pick this character and just simply break this, right? That is, we found s of j. And if we didn't found s of j, then we can just simply break the for loop, this inner for loop, right? And if we found s of j, now we have to consider this substring. But before considering this substring, we have to check whether it is a palindrome or not. The substring from I to j is present as a subsequence, but it must be a palindrome. Then only we can update the answer. So if dp of I comma j it is equals to true, then we update the answer. And yes, finally we return the maximum answer. So this was the solution for all the 4 problems of today's weekly contest. Hope you have learned something new, and make sure to write your feedback, and so that we can improve the discussion. There's a post lesson discussion and the problem set. So thank you everyone for joining this stream or watching this video, and have a good day. Good night.